In this video, I'll talk about how FromJS works and also show some of the source code. If you're watching this video, you've probably seen FromJS, but if you don't know what it does, it lets you select some place in the DOM and then shows you the origin of that data. So it might be some string literal in the source code, or it might be like data has been loaded over Ajax, something like that. So to demonstrate that a bit more, I have a simple demo which just concatenates 3 strings and then we're inspecting the result string. So if we look at each character in this string, we can say that each character ultimately came from somewhere else. So the C came from this C in the CD string literal, for example. And we can do that for every single string here. And ultimately this can be kind of displayed as a tree. We have the final value. The final value consists of a left part and a right part, and they were joined together in a binary expression. So there's 2 important concepts I want to kind of name briefly. One is the concept of an operation, which could be like a string literal or binary expression, and it's in bold in this tree. An operation has some inputs and then an output. For example, the binary expression takes a left input and a right input and has this kind of plus operator, and then it joins it together to A, B, C, D, E, F. The other is a concept of the traversal of the tree. So I can select a character in here, like the C, and then I can traverse where the C comes from. So I go through the tree and then find the string literal where the C originates. And doing the traversal, I'm basically looking at one of these operations here. So I know I'm looking to C. I know the 2 inputs are A, B, C, D, and E, F. And then do I need to look at the left or the right? Well, I have to look at the left in this case. Next time, another binary expression, A, B, and C, D. In this case, I have to look at the right, and that's kind of where I find the kind of origin string literal. So this is a very simple example, but it becomes more complex as you can add more operations. So if I do a slice call in here, for example, you can see I'm now concatenating a binary expression result and a call expression result. And the call expression is a bit more complex than a binary expression because it has a function, it has a context, which is this value, and then it has 2 arguments, which are kind of both numeric literals in this case. So if you see these operation names and you ever wrote a Babel plugin or worked with a JavaScript AST, you can probably see that they are basically node types in an abstract syntax tree. So if I look at the kind of AST in AST Explorer, I can see that I have the A string, which is a string literal, and I have the right part of the binary expression, which is another string literal node. They're combined by this binary expression with a left argument and a right argument, and so on. So FromJS is built on top of the Babel AST, and it takes a lot of those concepts over. So a lot of Babel node types are operation types in FromJS. So I have a simple JavaScript file here. So before we look at this in the actual tracking interface, I want to briefly explain how we can collect tracking data here. So one of the core things that FromJS does is that for every variable, there is another variable, which I just name by adding 3 underscores and a TV to it. So this is the tracking value for A, and this is the actual A value. And the tracking value just contains metadata about A. So if this is going to be the A string literal, the tracking value could be something like this. Could be like operation and string literal, something like that. Any additional information along those lines. Now this doesn't quite work yet. To actually get the proper tracking value, what we need to do is replace each of those operations with a function call. And then what the function call is going to do, it's going to just return A from the function, but it's also going to set a value, which is like the last operation tracking value, which is basically a global somewhere. And I can get that by calling the last operation tracking value LOT here. And then I do the same thing for B. And I'm going to modify this to take an array rather than a single value. And it'll be clear later on why I'm doing that. Okay, now we want to construct str. And alongside of it, str TV. And again, we're going to do last operation tracking value, and str is going to be a binary expression. And the binary expression is going to take a bunch of arguments, one of which is a, the other is b, and then finally I call those AST arguments because they're evident from the AST, like the operator, and they don't change at runtime. So what I've already have here is I'm passing the values into the binary expression. But the reason I'm passing an array in each case is because I also want to put the tracking value in here. So now I'm able to kind of create this operation log that contains all the data that I need to do the traversal later on. And the reason why we don't have a tracking value here is because this is where the value actually originates, so there's no additional tracking data yet. So let me just comment this out, and let's briefly look at what the actual result is going to look like. We can look at this, and you can see I'm looking at the binary expression. It has the arguments, and in here, this is basically what the value of ATV is. This is the data for ATV. The actual value of ATV at runtime is going to be this index, which is just used to look up data later on. And the reason it's an index rather than storing the whole thing is because that allows us to store the actual content of the log data on the server, and we can save memory in the browser by just storing the reference index here. There's a few other things in here that you haven't seen, like for example, I'm also storing the result, a serialized version of the result for each one. I'm storing a lock, which is the location in the source code. I'm doing that for two reasons. One, because I'm using it to kind of show where the source code is, because here you can see I show the source code, and that works by just identifying the kind of line and column based on this lock. The other reason why I have the lock is because I'm not actually storing the A, for example, because the A, if we know that we're looking at this string literal, we don't need to store the A, because it's just going to be redundant because we can look it up later on very easily. And for A, it doesn't matter. If you have a really long string or some other operation that's quite complex, it just saves memory and processing time. So I think a binary expression is probably a good example of something we want to kind of look at in the source code itself. So I have a file called operation.ts, which contains all the operations, for example, the binary expression. An operation in this file consists of three things: a Babel plugin visitor, a traverse function, and an exec function. So the visitor is called during the instrumentation phase, which can add all the extra logic, like the str, the binx, all the kind of argument logic, stuff like that, the tracking value variables. So this is where we're doing the kind of code modifications. So first of all, I'm not handling any other operators other than like the four basic ones. So there's not going to be any change for those. And then I'm creating a new node, which is an AST node, which is a call expression. So we have this binx function call that's being created here. It has a left argument and a right argument. The left argument is just the value. So this is the original node that we're going to have. Like in this case, it's going to be A. Then we have ATV, which isn't here because there is actually some extra complexity around how identifiers are handled. But basically, this identifier is going to be replaced by an operation, and then we get the last operation tracking call. We get the last operation tracking result from that, so we don't have to hard code ATV in there, because the left argument of a binary expression can be anything. It might not be a literal, it might be another binary expression or some other more complex thing. So that's why we do it this way. Then we have the operator that's being passed in, and we just take the operator directly as it is in the Babel AST. And then finally we have path.node.lock. So lock is what Babel gives us, which tells us the column number, the line number, stuff like that. Then there is the traverse function. The traverse function takes the operation log, it takes a character index in the result value of that operation, and then tries to figure out which of the arguments here we need to look at next. So there's only 2 arguments in a binary expression, and it has to be either the left one or the right one. And the one case we really care about is if the 2 things we're concatenating are strings. So we make sure that's the case, and then we do some other stuff called traverse string concat, which is in a different file. And basically, if we do like a plus b, and we are interested in character 1, we have something like this. So if the character index is less than the length of the first char, then we know we're in the first char, we're in the first string. Otherwise, we know we're in the right string, and we can adjust the character index for that. So initially we pass in character 1, but then inside this string, we'll actually add character 0, because we're at character 1 when we're in AB, so we're here, but then in the actual next value we're going to be looking at, we just add character 0. And then we just keep doing that. And I think a string literal is also going to be in here. It has some complexity just because it has this thing what I call shorthand that I'm using for certain very common operations for performance. But again, we have a visitor to kind of create this thing. I don't think we have a traverse function because it doesn't make any sense to have a traverse function on a string literal, because the string literal will always be the original source of the information. And then we have the exec function, which is also very simple because we're just taking the value of the string, which is the first argument. It's number 0 because 0 is the value, 1 would be the tracking value, which doesn't exist here anyway. So that's kind of a conceptual overview. Now let's actually look at the source code after it is compiled. We are looking at script.js, and you can see that most of this is actually kind of helper code that we have to handle lots of extra cases and actually implement stuff like the kind of call expression. And then at the very bottom, then we actually have the source code that we wrote ourselves. And it's not very pretty, so I'm going to put it in prettier quickly. So very similar to kind of what we discussed conceptually. We create the string literal alongside the tracking variable. Each one has a location that's passed in, and that's then stored as part of the log data. This very similar again. This is what I mentioned briefly about the identifier having some special logic. Basically pass in the value and the tracking value, and then we're able to do last operation tracking value to get that tracking value and pass it into the binary expression. What we didn't look at is the kind of call expression. And it looks kind of ugly because it has some special logic because call expressions are super common. So I think there are 3 arguments here. The first one is going to be the actual function. Change it in here. So this is the function. This is the execution context, and this is an argument. So you can see the function, we just get it by using FromJS inspect and then getting FromJS inspect tracking value. Because this is not actually part of the instrumented code, we need to check if this value actually exists, and it won't. So just there, so we don't get a runtime error for variables that aren't actually declared in track code. The execution context is undefined, has no tracking data because we're just calling it in a very simple way. We're not like calling it on an object or using something to like apply or something like that will allow us to pass in a context. And then finally we pass in the string. So that's basically how it works. One thing that I think is interesting is to take a look at the helper functions, which is most of what this stuff in here. Oh, yeah, which is what most of this stuff is. Like 99.9% of this file are just helper functions. And we can pause before every operation just to figure out like what is actually happening here. Okay, so we're in this op call because we're calling str, so it calls this op function, which creates some of the basic of the kind of operation tracking log data that we need, and then yeah, you can see it has some object args, which is the actual value of the string literal. You do that again. We have an identifier. We have a binary expression, and now if we look at the args, is the value of each of our string literals and the reference. So this is the kind of operation index or tracking value or whatever, and it allows us to look up what this A is. And in this case, it's going to be an identifier, and that's going to point to the string literals ultimately. So hopefully that explains what the fundamental concept is. And I'll just spend a few minutes kind of going through this source code and pointing out some things that might be interesting. Yeah, so we create this operation log. So this is going to be an integer. This is the object, which actually contains the data. And we set the last operation value result so we can get it later on with this kind of function call that we're using after each kind of operation. And there's a log queue, which is basically where all the logs that we're creating go. And to avoid running out of memory, if that gets really big, or like every, I don't know, 500 milliseconds, we try to send those to the server to get rid of them on the client. And yeah, as you can imagine, in the end, we just return the return value of the operation, which kind of makes sure that the application still works as normal, even though we have our own custom logic in it. I mentioned briefly some of the operations that we have. They're basically very similar to Babel. We have template literals, we have unary expressions, we have array expressions, all that kind of stuff. We also have a few special ones that are just kind of helper code really. For example, if you have a result of a JSON parse operation, to traverse that, we need to know like what key are you actually trying to access right now, and then we look at the JSON AST and try to find where the value is inside the JSON. So then call expressions are really complex actually, which is not great because they're also really common, so it's going to slow stuff down quite a bit. But basically we have this list of arguments that we need to kind of convert to be in the right shape. Sometimes the function that is actually being called actually receives different arguments than the function the call expression is defining. That's the case when using call or apply. There's some special cases for new expressions. So this is like when you do like new, I don't know, some class something. There is special logic if the function is eval, because the string in eval actually should be compiled first before we eval it. And that's also why every page is loading compile in browser, which is basically loading Babel, which is loading the Babel plugin, so it can do the compilation synchronously inside the browser. There's a lot of special cases for native functions like string.prototype.replace. So in order to traverse that, we need to know some information about the indices or the regular expression that was being used in the replace call. And I have a whole bunch of special case logic in here. Yeah, for string.prototype.replace, passing JSON, exec, array.prototype.push. So let's have a look at what array.prototype.push does in this special case. First of all, keep in mind that the push function can be called with multiple arguments. So for each argument, we go through the argument that's being pushed. You find out the array index where it's being pushed at, and then we track an object property assignment on the object. And basically what that does is allows us to find out later on where the value came from. So I guess if you imagine something like this, where you have some array, new array.push, hi, and then later on you do array 0. Where does this hi actually come from? And in order to do that, what we do is somewhere we have a map, which is like obj map of the R of index 0 is some tracking value. So later on in this member expression we can look that up. I can briefly show you what that is. So there's a member expression which has a special file. We do exec. Yeah, so we get the value here, which is simple, and then we do get object property tracking value, which has been set in the push function or inside an assignment expression or any of a bunch of different cases. We have the Babel plugin, which does all the transformations. Visitor is probably here, so we can see the operations and call the visitor on them. But there's also a bunch of logic for other things that can't be handled in the same way. So for example, a variable declaration. When you declare a variable, we also want to make sure that we create the tracking variable. So that's going to be the variable declaration is going to be var a, and we're going to make sure that we add the ATV to that, like this. And then do get the last operation tracking value. Oh, so one thing that is very annoying is mapping kind of DOM data, because the DOM is basically a string in the way that I'm looking at it for this case for FromJS. But obviously it's a set of objects and they're kind of mutated in like weird ways, and yeah, it's hard to figure out where a particular string in the DOM, particular character in the DOM actually maps to where this character was caused in the source code. So what I have is not very beautiful, but if you look at each of these elements, you have an L origin on them, and you can see where each of these parts comes from. So for example, what I'm looking at here has a few attributes. It does not actually have those attributes anymore, which is probably because I haven't implemented any logic for remove attribute. This might be more interesting because we're looking at a text node, and this would actually point us to a particular place. So I think if I inspect this text in the just navigate to, where is that? So we're getting this, and then the just navigate to is going to be selected, and based on this kind of L origin data, it will look up the right thing. Yeah. So yeah, you can see here, this is the tracking value that we want to look up for this. Yeah. Obviously, one thing you can see here has been logged to the console is the HTML to operation log mapping, which is basically this. This is being sent to the server, which is then being sent to this iframe on the side to kind of show that data. So in the network logs, you can also see these store logs operations, which just go to the localhost server and take a list of logs. And you can see, like, even for this kind of React application, there's lots and lots and lots of stuff happening, lots of operations. Yeah, and that's kind of what's being stored. For storage, I am mostly using LevelDB, so it's a log server, a LevelDB log server, or like a memory one, which just stores a key value pair of the object and the kind of tracking value number here, the index. So that's hopefully like a brief introduction, and that kind of explains the kind of concept behind FromJS and how it works. Yeah, feel free to ask me if you have questions.